Okay, welcome back. So now let's put sense into motion. So before that, remember all these dictionaries that we have used so far, exactly the same as the previous one. We haven't done anything new. The only things that we introduced, now extra utilities. So we created here the face sums, and then you have the extra utilities here that, for instance, create baffles, will read this dictionary, see that you are accessing that face sum that you created here, and then give these names. Okay, here, the only thing that this is your template, the only thing that you need to change is this name, and if you want this name, this always leave it as a patch, and that's all. Okay, nothing else. Here I'm not using the NCC, the dictionary for NCC in the two rotors. We're going to visit that. So at this point, let's put this body into motion. So you have this script, run move mesh. Okay, so basically to put it into motion, you have this phone run, and we'll use this solver moving mesh, and that's all. Okay, disable function objects. Be careful that there are a lot of function objects compute this and that, so as you're not computing solution might give you a problem. That's all. I don't recall if it will crash or any case. It's not a big of a deal. This run will also in parallel, we're going to run this in serial. Okay, it's super fast. We're just putting the body into motion. So the things here that I'm doing some manipulation and reading this dictionary mesh motion, so just to do things fast. So see that I don't have function objects. So let's take a look here. Run move mesh. And there you go. It's running there. It's putting the mesh into motion. And look at that, what I was telling you, a lot of information. This information is related to geometrical, let's call it geometrical conservation errors. No, the mismatch between faces. No, you have the owner and neighbor face, and that mismatch is being reported here. So ideally, the coverage should be close to 1. This one also should be close to 0. Angle probably is a little bit large. While it's not more than, let's say, 60, it is okay. And here, conservation volumes, these one are basically 0 machine precision. But when you start to compute the solution, you will get something. But see that here we run 1 second, and we should have our. So here you can check. You can you put the mesh into motion, and you check all these interpolation, geometrical interpolation errors, and so on, to see that everything is okay. So let's run Paraphone. And to put this into motion, and I want to visualize only the impeller. Right there. And there you go. Rotating, important. Okay, later we're going to revisit boundary conditions, but we have the chaff somewhere. There you go. Now I put the mesh. It's just the impeller that is rotating. The shaft is not rotating, okay? So then there is a specific boundary condition to add that rotation. Later we're going to see. So these are the small things, the physics that you need to understand. You need to know how to set up things and so on. And interesting here is to look at these two patches. Okay, these are the NCC. Recall that this is where things are happening. So what is happening there? Okay, and actually, let me do this. Let me extract here. Filters, extract block. Okay, it's becoming very, very messy. Why? Okay, so here I just need, no, I need NCC1. Why is selecting everything? Okay, filter, extract block. I want NCC1. Filter, extract block. NCC2, I forgot the impeller, but also the impeller here. Okay, so let me put this two here. I want this, I want this. Show me the mesh there. Show me the mesh also here. And I want solid color. Right click, link cameras. Okay, so you didn't know that. And there you go. So basically what we have here, one of these patches is going to be fixed and the other is going to move. Why the two are moving? This is the one. Okay. So here I have this and here I have this. Okay. There you go. So this is moving, this is fixed. So this patch, it is attached to the outer volume, the tank. And this one is attached to the cell inner volume. And it's moving, and here's where the interpolation is happening. Okay, so you can see clearly that Vice tried to have these two patches, okay, very, very similar. I know that I don't need to do that, but I have seen some people that I know forget about this one, this standard practice, and when they're doing the mesh and snappyHexMesh, they add different refinements, and then you get the internal patch much finer than the external. That is possible to do, by the way, so be careful about that. Okay, it needs to be very similar, and that can be controlled very easily. And then these issues that the snapping is, I criticize a lot this snapping, and always related to the aspect ratio that we have seen that it's a big issue. Then you have this problem here, you know, that it doesn't snap properly to that feature there, but it's not an issue. Okay, it managed to run the simulation, keep the errors low. Okay, but ideally also always check the edges to see if you don't have problems like that, big problems. So see here that kind of there. Okay, so this is checking the mesh. Also, by the way, when you run ParaView also will show you all this stuff. So if you miss that information for some reason, when you run ParaView, you're going to see all the geometrical check. And now let's do for list. And let me cancel all that. And I want to run the simulation. But before running the simulation, okay, let's revisit boundary conditions. So here you have run solver, so nothing changed. So I clean a little bit stuff and using SB constraint, whatever, run the simulation, and then go ahead. So let's open first. We have here the boundary file. So recall that we set up everything, nothing strange here. The only thing strange here that you will see is all this stuff. Remember, this is added automatically by the utility to create the NCC. Do not modify this information. Even if zero faces, do not modify, do not erase. So this is created automatically. So you don't need to do anything there. The rest, nothing. Here's where you set up the motion. Okay, so you have the dictionary, you put it there, you have some comments. Then let me go into boundary conditions. Okay, so now this file will be this because there is an so you have K turbulence model. So look at that in all files. I'm putting this. This is important because you need to set the boundary condition for those new patches. And this is a template that you have in OpenFOAM. So you add it there automatically, they're going to be set. So my advice, do not think about how to set those boundary conditions. Use the template, okay? And what I want to say here for you, okay, NCC, look at that, you need to use this specific patch. That is in the documentation, okay? Read the here in the website it is explained, okay, but if for some reason you don't read that, okay, you have here the comments how to set that. So very important, NCC, you use this, and then the impeller moving wall velocity, it is moving. And look at that, the shaft, what I mentioned, the shaft is not moving, it's not actually rotating, but you can add this sorter that is will be rotating at the same velocity and rotation, okay, to make sense. Consistent, then the rest, nothing else is moving, okay? So, but be careful with the NCC patch, moving wall slip, and then all the bodies that are moving wall velocity. For P, this NCC will be zero gradient, and whatever is moving, it is zero gradient. K omega node is a specific node treatment of turbulence modeling, but nothing fancy. You just need to put there the wall function or the treatment at the wall. NCC remains zero gradient. In all, there are zero gradient. Actually, should be calculated. Okay, actually, yeah, calculated. The only one that changes you. Okay, moving wall velocity. Then system, you have the control dictionary. Now the request this one. Nothing new here. The only thing that I have all these function object, but it's the standard one. I knew since that I added here, probably here to control the current to a maximum of 5. And then we have the numerics, okay? When it comes to the numerics, standard numerics, but when it comes to solution, you have this new entry, okay? So this new entry, it is to correct now the conservation of the NCC. So here you have a link. Also, it is in the documentation here in the website of the developers. And always enable this correction, okay? There is no reason to disable, and that's all. So at this point, let's put this body into motion and let's wait a while. So I go here, bam, 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 solver. And if I didn't do any mistake, okay, perfect. So see that important. Look at that. This is initialization. Very, very, very first, reading mesh and everything, and see that it's computing the interpolation, everything perfectly matching. And then after the first iteration, pimple here, one, you start to see that you start to get now the geometrical and conservation errors. And just follow the guidelines, similar meshes and so on. Also, not time step, not too large. If you choose a time step very large, no, the matching between the surfaces, the coverage will be very dissimilar. So try to control everything. Okay, so at this point, I will let it run. Also, let me open here and I come five flow. Now the fans are also going crazy. There you go. I put some monitors. Okay, so fully on a steady solution. So just to mention that this is a complex computation. And for those doing, I know, wind turbines, pretty much this is your your approach. And there you go. At this point, see you, I don't know, like in an hour. So see you later. Bye. Okay, so I'm back. I ran 1 second simulation time, I updated my control did, and we have here solution just to show you our residuals. Okay, perfect, nothing strange. And when I was talking about the continuity errors we have here, know that they should be small. Okay, can be positive, negative, it should be small. And I recall in a few cases using the AMI, these residuals were going really high, or sometimes I was having some high peaks to in the order of 10 - 2, and that's raise some concerns. Now that shouldn't be there. So now with sensitivity are much better. The pressure field also is much uniform. But in any case, just to show you there, we have the solution. It's up to you to run the 3 seconds or whatever you want. And let's do some post-processing. So this is critical as well, important. It's a standard post-processing, nothing changed. But what I want to mention, this error here, very annoying error. So for instance, we know that we have the solution in parallel decompose. So you use Paraphone built in, and it will let you access that information. Okay, so but if I go here, basically will crash. This error here. So it's kind of something similar for those do I already mentioned doing a Lagrangian particle. It's something similar. You cannot post-process in parallel. You need to go into serial. So you have that error. Sometimes can make your computer crash. Very annoying. So what you can do, in my case, I have two options. Well, there are a few options. So you can convert everything to VTK. Okay, so you get that in parallel, put it in VTK, post-process that data or any other format, reconstruct the case in serial, and you can post-process with no problem. Or let me check if this work. I have another version, ParaView 513, the newest one. The one that OpenFOAM use, and using the one that comes with OpenFOAM when I do the post processing is 511.2, and that one has problems. So now let me come here, open, and okay, so I forgot that I need to, this one doesn't create this file, case font, no, case font, part of view 513. Let me open that file, decompose case, and yeah, now it's working. It's giving you here something, but let me see, because also it's a little bit temperamental. Sometimes it crashes, sometimes it doesn't crash. And put it there. And yeah, this is one of the things that now I can access the queue field. Why? Uh, So I have this field, the Q field is selected. So it is one of these options, I think, copy. So these are those small things that are super annoying in Palaview or this. So let me see if this one manage. Okay, no, I don't see the field. So see that now it works, but for some reason, okay, I cannot access the field. Okay, the same error is not crashing, but I cannot. Man, but I recall that in another. Mm, well, also, I recall that I use another. Ah, okay. So let me select everything. Okay. Okay, I selected all the patches, and now it should be available. Okay, see here, you have it there. So now you can access. So I don't know what is the issue with those new patches. And there you go. You have your field. Well, it's a little bit tricky, as you see, you need to open. So I don't like to do that. And the way to do it, so you have that in mind, you need to take the long path. So you do the reconstruction in Syria, reconstruct par, it will reconstruct everything, and there you go. Or you can also do the conversion font to VTK or font to Insight, convert that data to another format and post-process. But you have this issue in parallel. Very annoying issue. I have to stress that. Has been reported already, and I don't know what the developers are doing regarding that. So now if I go here, I have the serial exactly the same stuff, but now everything is accessible. You don't have any more that problem. And you can do your post-processing in the standard way. So here I need to skip 0 time. Okay, it should be somewhere there. There you go. Another alternative is to compute K directly in ParaView, but that's a little bit time consuming. And there you go. We have that, and probably here, let me deselect, and I want only internal mesh. There you go. So now this moving and you're capturing here, in this case, Q criterion is used to capture the vertical structures. And there you go. Nice simulation, physically realistic results. You're ready to go. So at this point, okay, let me go. Let me stop here. So this is a sliding meshes approach. Remember that here we have access to the face zones, everything plus the NCC patches. And this, you can use it for the next simulation that we're going to do, or you can or you can stop before doing this step to creating the NCC. So at this point, let's move to the MRF approach.